Okay, so this morning we're going to get into the AM alignment on this Marantz 2120 tuner that we repaired the other day. Now, the directions leave a lot to be desired. There are a lot of things left out, and we're going to have to talk about some of those things and what we're going to do. Okay, so I want to show you the paperwork, and also I want to show you they said that they wanted a watt meter, voltmeter, variac, and all that. And I want to just give you a quick look at that. And then we'll talk about what they want, which is pretty ambiguous, and then what we're going to do. Okay, so Marantz is kind enough to give us a test equipment required list. For AM signal generator, they don't even specify what you want or what you need. It just says simply signal source for AM alignment. Test loop used with AM signal generator. We'll get to that when we start feeding signal in. FM signal generator and multiplex signal generator, here we go. They're specifying the Sound Technology Model 1000A. Now, if you remember when I was talking about generators, I mentioned this one and the Sencor, and they're both fine generators for what they are. But one of the other problems is everybody's buying them now, and the prices have been hyped up far in excess of what I believe they should really be going for, which is just another reason that I opted for the equipment that I have. Now, they have distortion analyzer, audio oscillator, and AC VTVM listed here. They're showing the Sound Technology Model 1700A. We're using the Keithley as our distortion analyzer. We're taking our audio either from the generator that is delivering the RF, or we can stand alone depending on what our needs are. AC VTVM, I have my HP out and I'll show you how I'm going to use it. Oscilloscope, they specify either a Tektronix T932 or a Philips 3232. I have a Tektronix scope, doesn't really matter because we're just using it for waveform analysis and troubleshooting. Frequency counter, Fluke 1900A, got an HP. Circuit tester, not even anything given. DC VTVM, Fluke 8000, digital Simpson, or triplet 801. These are basically digital multimeters. I don't know why they said VTVM, except the VTVM has a very high input impedance, as does digital, so I think that's why they specify those. AC watt meter, line voltmeter, and variable auto transformer, or variac. I have an AC watt meter and a line voltmeter that I'm plugged into. I believe I've shown that to you, but it was a $15 item from Amazon. Works great. So, AM IF alignment, they want us to connect a sweep generator to the L152 and an alignment scope to J267 test point. And they want us to rotate each core of the IF transformers L154 and L155 for maximum height and flat top symmetrical response. Now, what you see is going to depend a lot on the span of your sweep. You're not going to see a flat top unless you have a very narrow span. Anyhow, we're going to go and take a look at the sweep generator I'm going to use and how it works and how it connects. Okay, so this is my variac dim bulb tester in the back. And I want to point out this little guy. This was pointed out to me by a friend on Audio Karma, a guy named Art. And it was about $15 on Amazon. Shows voltage, current, power, or wattage, or an energy in kilowatt hours. Very handy little guy. So we have our tuner set at 120 volts, which is what they want. Okay, so we're going to start with the AM alignment. And boy, the first thing they tell you to do is connect the sweep generator to the L152 and the alignment scope to J267 test point. And then rotate each core of the IF transformers for maximum height and flat top symmetrical response. So what kind of sweep generator do they want? They don't say. How wide a sweep do they want? They don't say. They really don't tell you a whole lot. Now, when I first started out working on electronics, I was picking up TVs on the side of the road, and I would get the Sam's Photo Fact. Now, for those of you not familiar with those, they were just very, very comprehensive pieces of service literature. They would show pictures of the chassis with a grid laid over them so you could locate every single part. The schematics would fold out, and they would have little pictures of oscilloscope traces as well as voltages at certain points throughout the circuit. Very easy to see where your problems were. Then we go to equipment like this, not quite as good. So, what are we going to do? Well, I did a lot of reading on sweep alignment, sweep generators, and for sweeping, I wound up with a Hewlett-Packard 3336A, which is called a synthesizer / level generator. It will sweep, and we have to set up our oscilloscope at XY mode in order to see this. So out of the back comes what they call the X drive or pen drive for a chart recorder. We have to connect that to channel 1. So let's take a look at that and see how we set that up. But before we do, a single IF would yield something that looks like a Gaussian peak or curve. But we're dealing with 2 IFs, and this is more likely what you're going to see. Now, this happens to show a sweep width of 445 to 465 kilohertz. 455, of course, is right in the middle, and they're showing a width of 10 kilohertz. Now, depending on how wide a sweep you have is how flat a top you'll see. The narrower the sweep, the flatter the top will appear to be. I'll show you what that looks like. But meantime, we need to set up our scope and signal generator. So let me move over here so you can get a look at this. All right, so here's the scope and signal generator. Now right now, we just have a dot on the scope, which you can see right there. We're going to turn our generator on. And we're going to set a sweep that encompasses 60 kilohertz, 30 on each side of 455. So we're going to use a start frequency of 425 kilohertz, a stop frequency of 485 kilohertz. We're going to go with a sweep time of 0.01 seconds, and we're going to change that, and I will show you why. And we're going to go to continuous sweep. Now that we've done that, you see we have a line in the oscilloscope. So I'm going to focus on the scope here so you can see what we're doing. Sorry for all the motion here. And let me try not to trip over this. We want to make sure that our sweep encompasses exactly 10 divisions, because when we do that, our IF should fall directly in the center. So let's take a look and see what we get here. The other thing I need to do, which I neglected to do, is we need some signal out of here. So let's go to negative 40 dBm. Now we have something on our scope. One of the things I learned reading is if you have too high a sweep speed, you will get distortion. So I'm going to change this to 0.1. We're going to get some flicker, but you'll see that the response changes. Notice how different that looks now. I'm going to go back to 0.1. Watch closely. 0.01, I'm sorry. There, we lose our flicker, but we start to get distortions here. Let me turn that up so we can see it. So I'm going to go to 0.1 seconds. And we get flicker, but we get a better wave shape. Now, directly in the center is our 455 kilohertz IF. And there are two cores that we're going to rotate. I'm going to show you down inside the tuner, and then we'll go back to the scope. Okay, so we are going to rotate, and of course the probes are in the way here. We're going to rotate this core and this core. So let's go back, look at our scope, zoom in just a little, and I'm going to rotate the first core. And you can see we get quite a bit more gain. There are waves. We have a nice flat top. When I have the tool inserted, I'm going to go to a ceramic tool because even a small bit of metal like that can throw you off. These ceramic tools are great, but they are a little brittle. Okay, we have a pretty nice flat top there. Let's take a look at our other core. And we lose a little gain, so that's about peaked right there. Okay, so that's how you sweep the IF. I am currently sweeping at 60 kilohertz. This example shows 20 kilohertz, 10 on each side of 455. So let's see what that looks like. So, going to my generator, start frequency, 445 kilohertz, stop frequency, 465 kilohertz. Okay, you notice we have a wider presentation. Conversely, if I were to go to 100 kilohertz, it would look something like this, 405 kilohertz, 505 kilohertz. Now we have a very, very narrow, so it really depends on where you set your sweep. Most articles I read recommend somewhere between 40 and 60 kilohertz. And remember, that's going to be, if that's 60, it's going to be 30 kilohertz on each side of 455, which is 425 and 485. Or if we're going to 20 kilohertz, it's going to be 10 on each side. So you just kind of have to calculate that. So most of the things I read said to go 60 kilohertz. And that's what we get. That's how you sweep the IF. There are times I'll simply peak the IF during the alignment procedure, but I wanted to show you what sweeping looks like. Now there are a lot of cheap sweep generators out there you want to stay away from because you can do more damage with a piece of equipment like that. Some of them have markers. This one we don't have markers because we know as long as we sweep the entire width of the scope, that in the center will be our 455, because remember, we're sweeping an equal amount on each side of center. So synthesized generators are more expensive, but a cheap sweep generator is not really worth the money. So that takes us through our AM-IF alignment. Now we're going to go to the frequency range and tracking. So that necessitates a different setup. One thing I want to talk about is you want to isolate sources of noise which will cause problems during your alignment. Now with FM that's not as big a problem, but with AM just about anything can cause noise. So if we look here, this is my LED bench light. It adds a lot of noise. So we're not going to be using that. Okay, so what we are going to do is we need to connect our AM signal generator to the tuner. They don't really say what they want us to do here, but if you notice back here at the top it says AM signal generator test loop used with AM signal generator. So that's what we're going to do. I have a test loop, which is nothing more than a few wraps of wire connected to a piece of coax going to my signal generator. Okay, so we got that plugged into the 8657A, and we're going to set that up. So we just take the loop and we just hang it onto the loop stick antenna. Then we turn our generator on. And they want set the AM signal generator to 515 kilohertz, turn the tuning capacitor fully closed, placing the tuning pointer at the low end, and adjust the oscillator coil 153 for maximum audio output. So we have the output of the tuner connected to the input of the scope. We have the signal generator through the loop connected to the loop stick antenna. So let's set this up. Frequency 515 kilohertz. Our amplitude is going to be negative 60 dBm. And we are going to modulate AM at 50%. And now we need to find where our signal is. Now I have the tuner set all the way at the base. Let's take a look down at our tuner. And as you can see, the tuning capacitor is fully closed. Okay, so now we need to find L153. And see if we can find our signal. Oh, there we go. Okay. We're going to drop the amplitude of the generator to negative 70 dBm. We want to be right down there in the noise for this. Negative 75. Negative 80 dBm. And we just want to peak this. Okay, so that's our 515. The next thing they want from us is we want to set the generator to 1650, place the tuning pointer at the high end, and adjust capacitor trimmer C125. And we're going to repeat these steps, so we're going to set our generator up to toggle between them. So we want to go between 1650 and 515. $16.50 minus 515 equals an interval of 1.135 megahertz. So we're going to set our generator up for that. So frequency increments set 1.135 megahertz. So now our increment and decrement arrows will go to both ends. Okay, so now we need to set our tuner up to do the high end. This sets our dial range. Well, that's not bad. Now, another thing Marantz doesn't tell you is what our capacitor adjustments are on the tuner. But if you look, we have smaller vanes and larger vanes. All right, the larger ones will have more capacitance and the smaller ones will have less. FM is much higher in frequency, so that's going to be the smaller ones. Okay, the large fins here are AM. And you notice when we touch that, we lose our signal. Not so much on the other ones. So yeah, this is what we're adjusting. And I don't think we really need to adjust this, and you will find that they are very touchy, but just for demonstration purposes. Okay, that's pretty good. We're going to go back and forth between the two, but I think it's going to be pretty close. Now, the reason we want a very small signal, and we are at negative 80 dBm now, is you don't want the AGC, the automatic gain control, to kick in, because then you won't see your amplitude differences. So we have to use a very, very low level signal. Again, we don't need to know the absolute value, we just need to know it's low, right down there in the noise region. And one way you know whether your AGC is affecting things or not is to change the generator output. So if we change the generator output, go to negative 85 dBm, we should see our amplitude drop. And that tells us that our AGC is not affecting our adjustment. Okay, so I'm going to go back down to the base here. I'm sweeping the tuner all the way down to where the tuning capacitor is completely closed, and I'm going to decrement the generator, and we still have our signal. Remember, I dropped it to negative 85 dBm. Let's just see. I think we actually got this pretty close. Now, disclaimer, I was playing with this yesterday when I wasn't on camera. I think we're pretty good here. Usually you have to go back and forth many times, but we're going to say that's good. And now let's see what they want next. We want to go to 600 kilohertz, tune the tuner to the same frequency, and adjust a slug core in the ferrite rod antenna for maximum output. This can take quite a bit of adjustment, so let's see. Oh, and of course we want to make sure that we're not moving the loop, which will also affect our settings. So this is always fun. So I'm going to tune the tuner to 600 kilohertz, which is right here, and will hopefully fall into that range. Frequency 0.6 megahertz. Let's see, amplitude negative 70 dBm. And our dial appears to be quite a bit off. Quite a bit. Okay, folks, I'm going to take a quick look at this and see what's going on. Okay, so what I wound up having to do was realign the dial. I had marked it with a Sharpie, which I did not mention properly rubbed off. I should have scratched into the metal and plastic, or into the metal, to make sure we were lined up, but I didn't, so I had to realign the dial to the tuner shaft. Now the other problem is Marantz doesn't tell you which one of these tuning capacitors goes to what. So we have to figure that out on our own. As I pointed out, the smaller fins are FM. The larger, higher capacitance plates are AM. So we have AM here and AM here, which goes and corresponds to this tuning cap and this tuning cap. but we don't know which one is C124 or C125. And for that, I had to refer to the schematic. And if we look, we can see, and I had just seen this in our orange wire with this inductor in line goes to C124. That's going to be this guy right here. There's our inductor under the heat shrink, and that is C124, making this one C125. Now that we know which one is which, I was able to get a lot better of an alignment, slipping the dial, and now our error is minimal. But basically, that's all we have to do. We need to determine what we adjust, set the frequencies, and adjust to it. Now, we're at currently, let's see here, they want 1650, so that's 1.65 megahertz. There's our signal. For that, they want us to adjust C125. This guy down here is C125, and if I adjust that, you can see this is our signal. And we want to peak that out and then go back and forth. So we go all the way down to the base, decrement the generator, and we have good signal there. For that, we turn L153, inductors for low end, capacitors for high end. Okay, so this is going to be our max. I have the generator set to negative 75 dBm. And that looks good. Now I can also move the loop antenna. That looks pretty good. Amplitude negative 70 dBm. Looks like I'm getting some static from somewhere and I'm not sure where. We're going to turn the generator off. Yeah, we're picking up some, there might be a station down there. There's some kind of noise in the garage. I don't know. I know this light causes a lot. But anyway, we just go back and forth until we get good alignment on both ends at a low signal level. Okay? Now the other thing they want us to do is tune the antenna. So we tune the low end at 600 kilohertz. So our generator is going to set to 0.6 megahertz. We tune to 600 on the dial. There's our signal. And now for this, we have to turn the core inside the loop stick antenna itself. And it's okay to use a metal tool for this. And you're going to have to turn it quite a bit. This isn't just like a touch-up. It's not as touchy as a capacitor. This takes several turns. And you can see that this is 3 or 4, 5, 6 turns to peak this out. Okay? And again, this is something we do on the high end as well. We go to 1400. Alrighty, battery just died in my camera. I guess I need to charge that a little more often. So we are looking for 1400 kilohertz so we can tune the antenna at the high end. Let's see where we are here. There it is. Now that's going to be the orange wire here. Remember, this is coming straight from our antenna, and if we look at our scope, we just want to dial that for maximum. A little touchy, just like all the capacitors, but that's about max. We're going to drop the signal level. Okay, we want a really, really low signal. We want to make sure our AGC is not affecting anything. And you can see how much easier it is now. If you overload it, you'll never get a good adjustment. You need to be right down in the noise level to make sure you're avoiding AGC action. Let's go back to 600. Where are we at here? I'm getting quite a few radio stations. Let's see. There we go. Should be right around here. You may find as you go through you need to drop your signal levels. Okay. All right, that's looking pretty good. Okay, so to recap, what we've done is we've gone through, we aligned, we swept our IF, then we used the loop antenna off the 8657A to inject signals at each end of the spectrum. Tuning capacitor fully open, closed, tuning capacitor fully open. We set our frequencies on the generator to match the tuner and adjust these points. Remember, you're always going to adjust coils for low frequency and capacitors for high frequencies. We also looked at our tuning capacitor to determine which of the trimmers are which because they're not marked and the manual doesn't tell you. The manual, I have to say, is fairly poor and leaves out a lot of things. We are coupling our antenna using what they refer to as a test loop, just a few wraps of wire soldered on the end of a coax connected to our generator. All right, and we went through all these steps until everything fell into place. So remember, you need to use a very, very weak signal to avoid your AGC causing you problems. So I'm going to stop this video here and post it up. We're going to go next to FM and possibly even another one for FM stereo, just seeing how involved our adjustments are. As always, I hope you learned something. I enjoyed making this video, and I like to give back to the community that has given me so much. Thanks a lot, folks. Have a good day.